All right, welcome one, welcome all. How are you guys today? I'm glad to hear it. I hope you guys are well. I hope this does nothing to change that. It is Tuesday, our second happiest day of the week. We've been working on images formed by lenses and mirrors, and so I thought that in our problem session today we could try a couple of examples in that vein. I already started doing this problem and then we realized that we weren't recording. Sorry about that. So I'm going to reset a little bit. Apologies. We have a goldfish swimming at the equator of a spherical goldfish bowl filled with water. The radius of curvature of the bowl is 15 centimeters. We're going to assume that the glass is thin enough that we can ignore any refraction in the glass. Index of refraction of the water we'll take to be 1.33. For the air, we'll take to be 1. The goldfish is 10 centimeters away from the boundary between the water and the air, and so we'll set the object distance to be 10 centimeters. We'd like to know where our observer sees the image of the fish. And so we're going to use our equation that n1 over p plus n2 over q is n2 minus n1 over the radius of curvature. The radius of curvature here we need to take to be negative because for the object here, what we're seeing is a concave surface. So light coming out, right? So plugging in numbers, this is just algebra at this point. 1.33 n1 over 10 centimeters, our object distance, is n2 is 1 over q, what we're trying to solve for. n2 minus n1 over r. Plugging in values, I think that you get, we said, minus 9 centimeters, so we actually see the fish here. Does that make sense? Okay, so I'm sure it makes more sense the second time. Let's try another example. So we have an object that is 38 centimeters in front of a diverging lens, focal length 24 centimeters. Notice that I gave you the absolute value. Remember, our diverging lens, focal length should be less than 0, so minus 24 centimeters. If we want to find the location of the image, the image is observed to be at, well, we can use 1 over p plus 1 over q is 1 over f. And so 1 over 38 centimeters plus 1 over q is 1 over minus 24 centimeters. And so 1 over q over minus 24 centimeters minus 1 over 38 centimeters. So let's see. negative minus 24 divided by 24 divided by 38, and then inverted, we get that Q is about minus 14.71 centimeters. And then if we wanted to get the magnification, remember, is just minus Q over P. And so that'll be 14.71 centimeters over 38 centimeters is, give or take, 0.387. Is that kind of all right? Not terrible, at least. Most of these problems are somewhat of the plug-and-chug variety. So let's try an example where we have a pair of lenses. In this case, two converging lenses, each focal length 15 centimeters. We're going to put an object 10 centimeters in front of the first lens, and the two lenses are themselves separated by 6 centimeters. And so we talked about this in lecture, but the approach here is kind of like dominoes. We're gonna use the image of the first lens as the object of the second lens, and so on and so forth in combination, right? So let's say that 1 over P plus 1 over Q, and I'll just subscript I. Like so. So we could say that 1 over 10 centimeters plus 1 over Q1 is 1 over 15 centimeters. And so 1 over Q1 is 1 over 15 centimeters minus 1 over 10 centimeters, which is what? 10 over 150 centimeters minus 15 over 150 centimeters is minus 5 over 150 centimeters. So Q1, is that just 30? It's minus 30 centimeters. So then that puts the image somewhere off screen, sadly, somewhere way back here, right? But we can use that. So we could say that 1 over P2 plus 1 over Q2 is 1 over F2. And remember that the image for the first lens is the object for the second. So the image for the first lens is 30 centimeters behind the first lens, right, somewhere back here. That puts it 30 centimeters plus 6 centimeters in front of the second lens. And so we can say that 1 over 36 centimeters plus 1 over Q2 is 1 over 15 centimeters. This lets me say that Q2, well, let's do this in steps. 1 over Q2 is 1 over 15 centimeters minus 1 over 36 centimeters, or 36 over 15 times 36 centimeters minus 15 over 15 times 36 centimeters. And so, what is that? 21 divided by 15 and then divided by 36. So Q2 winds up being 25.71 centimeters. At least that's about what I get. Let's look at the magnification of the first image. So magnification of the first image is minus Q1 over P1, which is going to be 30 centimeters over 10 centimeters is 3. Call that M1. The magnification for the second one is going to be minus 25.71 centimeters over our object distance, which was 36 centimeters, is minus 0.7143. And so then M total just winds up being M1 times M2 looks like minus 2.14. So size a little more than twice as great, but inverted. It's okay? All right. Then let's try another in the same vein. Try and do this one a little quicker. So this time, converging and diverging lens, focal length 12 centimeter and minus 32 centimeters respectively. The object 18 centimeters in front of the first lens, the two lenses spaced 22 centimeters apart. Again, we're going to use the image from the first lens as the object for the second lens. And so for the first lens, we can say that 1 over P1 plus 1 over Q1 is equal to 1 over F1. So 1 over 18 centimeters plus 1 over Q1 is 1 over 12 centimeters. So 1 over Q1 is equal to 1 over 12 centimeters minus 1 over 18 centimeters. I can do this for 36, right? So that's 3 over 36 centimeters minus 2 over 36 centimeters is 1 over 36 centimeters. It tells me that Q1 is going to be 36 centimeters. Just so that we can stay ahead of the game, the magnification for this first lens is going to be minus 36 centimeters over the object distance, which was 18 centimeters, is minus 2. Yay?
Why it's minus?
Because remember that our equation is minus q over p.
Oh, okay.
So now this becomes the object for our second lens. And so 36 centimeters from here puts, so that's 22, need to go like another 14, so maybe to here. I want to be about twice as big. And so this is the first image, right? The image from the first lens. We want to use this as the object for our second lens. And so this distance should be 14 centimeters, right? If this is 36 centimeters, this is 22, that's got to be 14. We can say that 1 over P2 plus 1 over Q2 is equal to 1 over F2. And so 1 over minus 14 centimeters, minus because it's on the other side, right, is equal to, oops, plus 1 over Q2 is equal to 1 over minus 32 centimeters. So 1 over Q2 is equal to 1 over 14 centimeters minus 1 over 32 centimeters is 32 over 14 times 32 centimeters minus 14 over 14 times 32 centimeters is 18 over 14 times 32 centimeters. Tells me that Q2 is about 24.88 centimeters. Puts it, oh, and let's check out the magnification. M2 winds up being minus 24.88 centimeters over I minus 14 centimeters. Makes that about 1.77, 1.78. And so the overall image is 24.88 centimeters. I don't know if that's, and it's a little less than twice as big. So this is I2. If we want the overall magnification, that's not good. We want the overall magnification m1 times m2. So minus 2 times about 1.78. It's roughly, what is that? 3.56. So it's about 3.56 times as big as the original. So this is supposed to be about 3.56 times taller, but pointed in the opposite direction. Yay?
Yeah.
Let's try one more, because I'm already over time. So if this was one 1 centimeter tall object, then this should be about 3.56 centimeters, right?
Yeah.
Okay, so let's try one that has a lens and a mirror. And so converging lens, 20 centimeters, concave mirror, I don't know, I randomly guessed 20 centimeters. I haven't tried this, so we're about to find out whether or not this problem makes any sense whatsoever. I put them 10 centimeters apart, and I put the object 40 centimeters in front of our lens, and so we can say that 1 over 40 centimeters plus 1 over Q1 is 1 over 20 centimeters. Yay?
Yeah.
And so 1 over Q1 is 1 over 20 centimeters minus 1 over 40 centimeters, which is 2 over 40 centimeters minus 1 over 40 centimeters is 1 over 40 centimeters. Tells me that Q1 should be 40 centimeters.
Yeah.
And so that makes me think that it should be, there's a serious scaling problem here, but here, and that this distance needs to be 30 centimeters, right? Because 10 plus 30 is our 40.
Yeah.
That works.
Yes.
So then we could just go with this and say that M1 is minus 40 centimeters over our object distance was 40 centimeters. So this is minus 1. So this should have the same height as this. Yay?
Yeah.
Just inverted. Then this becomes the image for our mirror, right? Now, this is kind of a weird idea, right? That the object is behind the mirror. In everyday situations, you couldn't do that. But here, what's really happening is you're taking rays that are converging from this lens that haven't quite converged yet. They would converge behind the mirror, but they're going to hit the mirror before they do that. And so it's as though there were an object back here according to the mirror. And so let's try and see what happens. So we'd say that 1 over P plus 1 over Q for the mirror is also 1 over F for the mirror. This time we have 1 over minus 30 centimeters. Right, the object is behind. Plus 1 over Q is 1 over 20 centimeters. We get that 1 over Q is 1 over 20 centimeters plus 1 over 30 centimeters. I'm going to just put these both over
60.
over 60. Yeah. So let's say
60.
3 over 60 centimeters plus 2 over 60 centimeters is 5 over 60.
Yeah,
And so Q should be 12, is that right?
yes.
Don't let me mess this up.
It is.
Okay. So then, M is going to be minus 12 centimeters over minus 30 centimeters. It's going to be, let's see, divide both by 6, 2/5. Is that right?
Yeah.
Okay. So I think that our image winds up looking like this, where this distance is 12 centimeters. And the size of this, well, M total, right? Keep grabbing the wrong pen. M total is M1 times M2. That's minus 1 times 2/5. It's just minus 2/5. So it's oppositely pointed from the object. It's upside down, right? Inverted.
Yeah.
And it's about 40% as tall. That's I think that's probably true. Questions, comments, concerns?
So actually, that 2 over 5 is compared to the original object, right?
In this case, yes, but normally, it's M2 should be how big this guy got scaled, right? But
Yeah.
because this one is the same size as this one,
Oh,
this time it does work out that way.
oh.
But in the problem that we did over here, this 1.78 means that this is supposed to be 1.78 times this,
Oh, okay.
right? So this is our I1, this is our I2. The I2 though is actually the ultimate thing that you see, right?
Yeah.
So. Questions, comments, concerns? We're all right?
Yeah, okay.
Okay, then I'm gonna stop this here. As always, you guys are awesome. Have wonderful days. Thanks for stopping by. Don't be strangers. Enjoy our days, but not so much. We won't see you next time.